Hey everyone, welcome back to RemoteSensingPro. Today we are learning how to extract water from satellite images using the Normalized Difference Water Index, NDWI. NDWI uses the green and near infrared bands to highlight water. Water usually has positive NDWI values, while land and vegetation are near zero or negative. We will calculate NDWI, create a water mask, and draw water boundaries in Python. If this sounds useful, like the video and subscribe so you don't miss the next tutorials. Okay. So now let's get the bands that we need for the NDWI calculation. Okay, we need band 3 and band 5. We're going to, first of all, do a recap of band preparation that we've learned earlier. And secondly, we'll calculate the NDWI, then visualize the result. And then for the fourth step, we're going to extract water mask. And finally, we will visualize water boundaries. All right, let's start with band preparation. So I'm going to come here. This is what we did in the last tutorial 7. All right, I'm going to get everything we have here for NDWI calculation. Okay, so the first thing we need to do is to prepare our bands. To do that, we just need these two set of codes here. The first is to import glob, and we need this to be able to locate the bands we need in the folder. So we're using the cropped image folder. This has been consistent so far in this tutorial. Okay, and so we need band 3. And so we're going to change the extension to band 3. All right. Remember, when we did NDVI, we used band 4 and 5. So today we're going to use band 3 and 5. And these bands are the band 3 is the green band, and band 5 remains the near infrared. So we're not going to change this one. All right, so after we've grabbed the bands we need using glob, the next is to open the bands and read the bands using rasteria as usual. Okay, so we're going to change this to band 3, which is the green band, and this remains band 5. All right, so we've got what we need for the first cell. Okay, so I think we're good. We have band 3, we have band 3, and then we have band 5. I'll go ahead and run this code. Awesome. So now for calculating NDWI, we're going to modify the code we use for NDVI so we can use it to calculate our NDWI by just modifying the equation here. All right, we're going to start from this part. So we want to use NumPy as NP to, first of all, convert the bands array, and we're going to start using the green. We want to change the red to green, and here we also have green. Okay, this is important to make sure you change them properly. So we have the green to float 32. We have the near infrared to float 32 as well. And then after that, you don't really need this state, else we have error, then we can just add that. Okay, so I'm going to change this to NDWI, just like change everything here from V's to W's. All right, I'm going to do that quickly. We have all the NDVIs to NDWIs. Again, this is not part of this cell, so I'm going to take it out from there. All right, so this is what we're working on here. We're going to have green here. We have green minus near infrared. And then we have green here as well. Green plus near infrared. Okay. So this is the equation for NDWI. So here we want to set all the invalid pixels or pixels that are equal to 0 to NaN as usual. Okay, and we just need to set this denominator here. Change it for the one we did before. All right, so our equation is ready, and we can now run the NDWI equation. Let me have a look one more time. Green, near red, equation, green minus near red divided by green plus near red. And then we have NP dot where the denominator, green plus near red, is equal to 0. So we set to NaN, and we are doing that within the NDWI. Okay, so we're good to go. We're going to run this code right now to calculate the NDWI. Awesome. The next is to visualize the result, which is the last part of the code I copied earlier, right? All right, so let's have a look at that. So we need the matplotlib.pyplot as PLT as usual. And then we want to visualize our NDWI. We start by setting the fixed size. Maybe today I will do 5 by 5. Okay, to minimize the size. And so what we want to do here is to plot this NDWI. I mean, this last one for sure. We're going to plot this NDWI. And then we want to change this to NDWI map, right? So we're changing everything here to our NDWI, including our level, NDWI. Okay. And we also want to print the mean and the max values for the NDWI. Let me change everything here. All right. One more thing, CMAP. Okay, we don't want to use red, yellow, and green for water. So we do blues. Yeah, like more blues. Actually, this is not the best, but we just want to use it just to visualize the result first of all. Then we can customize it after that. Let me plot this. We've got the result. So let me just change this to BRBG. Okay, I think I found the best color. BRBG. Awesome. This should give the best color. Good. So we've got the highest value here at the top and the lowest one below. So you can see the land or anything outside water is kind of like below here, and the water is just above 0 right here. I think that makes more sense. All right. Okay, so now we want to extract water mass. And by the way, we have the mean and max value. And so we've got the mean here, the minimum to be minus 0.5. And we have the maximum for this NDWI to be 0.47 within this location. But just looking at this this map, I'm just going to threshold the NDWI here, like just at 0.0. Before you go ahead to threshold yours in your study area, please ensure to have a look at the pixel values to get to understand your image, to get to understand your study area before you make the decision on what threshold you want to use for your water. Okay, next is to extract the water mass. To do that, we just need to threshold the value that we have right here. Okay, I'm going to go with the 0 like I said. I will just do water threshold is going to be 0.0. And then we'll get our water mass. The water mass is equal to, want to do NDWI is greater than our threshold. Okay, the water threshold. NDWI greater than this water threshold. So anything greater than 0.0 is our max for water. Okay, so we're going to run this code. Awesome. Now let's visualize the result. PLT the figure. We're gonna do the fig size. is equal to, I'll do 5 by 5. And the next is PLT dot info. We want to show the water mask that we have. I will do CMap. So I'm going to just keep one CMap here. I will just call it water CMap. Okay. So I'm going to stop here and get my water CMap. This is very, very important. Okay. To get my customized water CMap that I just have in my head, to do that, we just have to use the method we used in our last tutorial by using the listed color map from my click dot colors import listed color map. You remember this library, right? Okay, can we remove this? And so I'm just gonna do water CMap, just this water CMap that I have here, right? I just want to bring it here. I want to create this so I can use it for this intro here. So to do that, I just do listed color map. Okay. So I'm going to give it color for the two classes, which is 1 and 0, right? So I will just do one because I'm not interested in the land. I'm only interested in the water part. And then I will just do the second to be blue color because it's water, right? Also. So I've got my C map for water, which I'm going to use here. If that makes sense, great. Okay, let's go ahead. We have water mask, and we have our color field customized. Also, so I will just do PL2 the show. Okay. All right, so here we are. So we've got the blue color because I customized it here to be blue color, and then we have the rest to be transparent. So when we set none, it means that we don't want to see anything here, any color here. We just want to keep it transparent. It's important to always use this, the color map, because it kind of helps you to customize your color anytime, let's say I don't want this blue. I want to use a different type of blue, for instance. Let's say light blue. Yeah, let me put light here. All right, so it kind of changes it for you. And sometimes you might want to use a different color code. Like this, there's this particular one I love so much. That's 33A1. I think it's 1E0. Let me give it a try. 1E0. Let me see if it's gonna help. Good. Yeah, this is my best blue color actually. So you can easily customize your color using this listed color map instead of just going with CMap and red, blue, green, or something like that. All right. So we've got the water to be this color, and the rest you can see they are transparent. We're not interested in any other class outside the water. Okay. Now let's go ahead to visualize the water boundaries. To visualize the water boundaries, we want to just create the boundary between water, which is 1 and 0, the non-water part. So we want to just bring down everything here. Not everything actually, it's just this one. Okay, so we start by bringing down this because we're interested in water mask, right? So we're going to use the same plt.imshow, but here we want to bring in the non-pi ones like. So ones like sort of focuses on the ones which are the water. Non-pi dot ones like. Okay. Once we have numpy dot ones like, we just need to get water mask for that because that's what we're interested in. And we still have CMap, But now we are not interested in this. Actually, for boundary delineation, use colors like gray, black, or red. Like, I think it's more common. But you can customize your boundary if you don't like these common colors. So I would just do gray for that. And if you want to also set the min and max, which is 0 and 1, we do vmin is equal to 0, and vmax is equal to 1. Okay, so we have this ready. All right, to create a boundary, you need a contour because you are more like contouring your map at this point, right? Okay, so we do PLT the contour. Want to contour the water mask. Okay, and next is the boundary. So the boundary between 0 and 1 is what? That's 0.5. All right, so we get the levels to be 0.5. Okay, I think we're good to go. But let's set some of the symbology. All right, so let's get a color. You can still do without colors, but sometimes I love to take control of my map. So I will just do black here. And I think that's all. Yes, one more thing. But let's run this code first of all, then decide if we want to add more things. Let's see. Water mask, gray, 0 and 1. And we have our water mask here. We have the levels, ready 0.5. We have the colors with black. And I think we're good. So we can go ahead and run this code. So it's in black, as you can see here. And so you can see that this is the water and this is land. So this line right here is trying to tell you that, okay, this is the boundary between water and land. All right, so let me just add one more symbology here. The line width. So line width sometimes kind of help control like how thick the line is going to look like or how thin, right? So let me give you an instance. Let me just do 3. So this is quite thick, right? So I will usually go with 0.5 because it's quite like, that's my best, 0.5 or 1. Sometimes you go with 1 though. See, this is perfect. This looks so good. All right, so 0.5 is my best line width, and you can always go with the one that works for you. If you like the lines to be thicker, you can do 1, 2, 3, or 4 as you wish. And let's clean up this map a bit. We'll just do PLT the axis. We'll put it off. All right. Good. So that looks good right now. And you can always leave the axis if you want. But I love to remove anything that will make the map busy. All right. So here is our water boundary. So that's it for today. We've explained NDWI, calculated NDWI, extracted a water mask from NDWI, and even drew the water boundaries. So this is a great starting point for water detection in remote sensing. If you found this helpful, please like the video and subscribe to Remote Sensing Pro for more remote sensing and GIS tutorials. Okay, see you in the next one.